Good morning, everyone. I'm Parag Pradhan. I welcome you to this demo session on data science. Uh, so we will be, so we, I have a hard stop at 12, so we will have, let's utilize this forum and this platform to answer all your questions that you may have during the session. Feel free to utilize the necessary slot to answer all the relevant questions, your doubts, your queries pertaining to the career in data science. Because at the end of the day, if you're going to invest your time, your efforts, and money into something you wish to do in your career, it's better you get it clarified. So, with that, I'll just give a quick introduction about me, and then I have few slides. I will not bore you guys with a lot of slides or a lot of jargons, but I will come directly to the point. So, let's start with my introduction. I'm Parag Pradhan. I have close to 17 years of experience now working into different domains, but predominantly into financial and that too into investment banking domain. Out of 17 years, last 10 years have been around in the field of data mining, data science. So data mining, I consider this field as a data mining. That's what um, we used to call back 10 years back when it was not even named data science. Um, and prior to that, I was into project management as well. I've worked with some of the large investment banks, the global investment banks. Uh, I conduct these sessions as and when I get time. So I generally do only two to three sessions per year. The main motto of mine to conduct these sessions is to share my own experiences, my own do's and don'ts with the candidates, so that when you start your journey in this field, it's a very vast and complex field. So, based on my own learnings, my own failures, my own successes, I try to give you a path that I hope that helps people to create their own journey, and it's in line with what they want. So, with that, let me jump into basic introduction to what data science is all about. Then I'll talk about the topics that I generally cover. What what are the big components within the concept of or the universe of data science, and then I will open the forum for your questions. So let's take a quick visit to the history of overall industrial revolution. So I'm sure many of you would have seen this in your economic books in school days, but there is an addition to it now. So around 17th century, end of 17th century, steam engines, the steam engines were designed and developed to harness energy out of steam. That led to steam engines, trains which help to mobilize goods, human resources, move fast between two long distances places, which help to mobilize goods and services at a much faster rate. That created a specific type of industry. It gave impetus to industry. Then we move into industry 2.0. That's when around 19th century electricity, especially the AC and DC power supply, which was started by Edison and the late great Nikola Tesla, that led to mass scale automation or mass scale of manufacturing, as proved by the likes of Henry Ford and even at Toyota. So that increased the productivity of humans, productivity of goods, made a lot of goods much cheaper than what they used to be earlier made. Then we move into the late 80s and early 90s with the advent of computers. It created a new age of revolution with automation, which would automate some mundane tasks, uh, likes of like banking moving into computers. Like I still recollect 20, 25 years back when I was in school, if I have to go to a bank to get my parents' passbooks. One of these Saturday activities I used to have is, and I'm sure many of the kids of my age would have done that. That they would be given a passbook of a bank, and you would be asked to go on a weekend to get it updated. And you have to stand in a long queue on Saturday, wherein you have to stand there just to get your passbook updated. So what is the purpose of a passbook? It helps you to see what do you have in your existing account, and what were all the transactions that happened. With the help of computers, all of that is now automated. Even today, on a piece of, like, a handheld device like mobile, you could get to see all the transactions that you have made so far in a particular month, and you did not have to go to a bank, stand in a long queue to get a passbook updated. Now we are talking about Industrial Revolution 4.0. We are already in Industrial Revolution 4.0. What does it include? It includes IoT, Internet of Things, wherein I can control the speed of my fan, or the room temperature of my AC, even if I'm sitting in a place like Mumbai using my mobile. Why? Because my phone is connected to all the devices in my home. All of that is possible because of IoT. Then the amount of data that we are generating has also led to concepts such as cloud computing, wherein your data need not be there on your local machine, such as a laptop or or a desktop, but it resides on a common cloud services, more like a distributed platform wherein your data is secured and can be accessed anywhere from any devices. Along with that, we also have artificial intelligence coming up, which is taking the age of automation to the next layer or next level, which is what I'm going to talk more about in today's session. So, welcome to the world of data. Industrial Revolution 4.0, which I just showed previously, all of these IoT, cybersecurity, your cloud computing, your augmented reality, your artificial intelligence, even blockchain, all of that is uh, has a base which is data. All of them are dependent on data. So we'll see what data is all about and why are we talking about it. So if I slightly go back, let's say 24 years back, uh, around 1998, that was the first time I heard the name Google, and I was still in school back then. So if I take myself 20 years back, and if I would have asked myself a question, what is a Google? My answer would have been Google is a search engine or internet that helps me to find web pages. And that was it. That's all Google was. So today, when I ask you this question, what is Google? The answer will be much more complicated. Google is, of course, a search engine, it still is. Google is into self-driving cars. Google helps you to uh, navigate to different places using maps. Then Google is an operating system in your mobile phones. Google is a place where you can listen to music, watch videos. Right now, we are conversing on a platform which is Google. So, all of these things are basically Google. So, what made from a small, no profit company, which was a small search engine, more like a small project, which ended up being such a large, complex organization. And the base to that is data. And how is it? Let's see. When you search on internet, what is that you are trying to do? You are trying to search for websites. But from the point of view of Google, Google is able to collect data about what people are thinking at that given time. right? When you're searching for a specific website, which means at that particular time you're thinking about something. So we are in a way giving power back to Google to understand what we are searching. So one of the main purpose of Larry Page and Sergey Brin, the co-founders of Google, they kept everything free, of course, because they wanted to understand what do people think. And around 2002, that's when they realized by analyzing this data, pardon me, of the searches which the people were making, they analyzed it to realize that soon people will need computation as accessible as, they should be able to carry a small computing device in their pocket. So it was around 2002, that's when they started researching and working on building an operating system for handheld devices, also called as mobile phones, which brings computation to the users, which they can carry everywhere and do everything that we do on a piece of laptop. So that brings me back to the point of data. When today data also gets created because of the amount of social media which is there, with the likes of Meta, or even with the likes of your YouTube, Instagram. Even right now what we are interacting, there is a video, that's a data, there is an audio, that's a data, the PowerPoint that I'm showing, that is also a data. Now all of this data is being generated at tremendous speed and at tremendous volume, and up till now people were able to store a limited amount of data, but because of cloud computing we are able to store humongous amount of data at a very fast speed. Storing data is all fine, but what does it mean? I mean, unless you analyze your data, you are not going to understand what it is all about. This is what led to concept of how do we analyze this humongous data and various form of data. So earlier when we talk about data, data would mean rows and column data in some sort of a spreadsheet. But today data would be audio, today data means video files, today data means uh, your text. So analyzing them needs a separate science to understand what is the information hidden in this data. This is the information which is what we call it as actionable insights for an organization. Now, when an organization gets these actionable insights, as the example of Google that I gave you, the companies are able to utilize this actionable insight hidden in such complex variety of data to either gain a competitive advantage, or to synchronize their operational activities, or to increase revenues, or even save their cost. So this whole science of analyzing this vast amount of complex data, it basically borrows from a lot of computational sciences. It borrows a lot of concepts from mathematics, and a combination of this has led to a new concept or a new subject altogether, which is called as data science. And if I have to in one sentence define data science is everything that we do to decipher patterns, to identify patterns and actionable insights from vast amount of varied and complex data. Okay, so I'll move to the next one. Before I jump into the actual course, there is these three terminologies are very much important to take a look at it. And when I initially started, I think couple of years into this field, these three terminologies, and in fact even today they are even more commonly used. They were interchangeably used along with the word data science, and there is too much of confusion around it. So let me try and explain all these three, so that at least by end of today's session, whether you have understood anything or not, you at least have a clear understanding of what these three terminologies mean. So the first one is artificial intelligence. What is artificial intelligence? In the simple terms, we as humans, we humans have a specific set of functionality that we carry. We talk, we walk, we speak, we see, and we sense. If the same functionalities are given to a machine, let's say, I'm sure all of you would be aware of multiverse. People talk about multiverse these days. Let's say in a multiverse, whatever right now I'm speaking, there is a machine that does the same thing. So giving the making a machine act like a human, or at least carry out some of the functionalities of a human, that machine can be considered as an artificial intelligent being. Now, just like humans, we have brains. What do brains do? Brain of a human is a component which helps us to take decisions. Similarly, for these machines or these artificial intelligent machines, there is a concept called as machine learning. So let me tell you what machine learning is all about. Machine learning is, let's say, when we grow up, or like even in your past when you were kids, your parents taught you, your teachers would teach you, they would help you in taking decisions, or rather they would take decisions on your behalf. Let's say now you are 18-year-old, and for your education you go out of your town or out of your city and staying alone. Now there is a situation that you have to take a decision. Now you do not have your parents near you, you do not have your the comfort of your teachers around you, but based on what you have learned in your past 18 years, you take a decision. That decision is based on your own experiences of past. Then once you take that decision, after few weeks or few months down the line, you realize that decision was incorrect. So now what you try to do, you have learned on your own, you have learned that the outcome of a specific action was incorrect. So now let's say 1 month down the line, you again face a similar situation. Now you try to rectify your decision making. You realize, no, last time I took a decision which was incorrect, so let me try and slightly change it and then try and act. Now you do it accordingly. This time it's a success. So what you have done, you have used your historical learning. You made a decision, it didn't work, then you slightly changed it. And during all of this, you don't have your parents to help you, you don't have your teachers to help you. It's you who you are learning, self-learning, learning, even unlearning to improve, so that you achieve a given task. You continue to improve your performance of achieving that task based on your historical learning. Same is the concept of machine learning. It basically enables computers to do a task with improved performance based on historical past, or based on historical learnings. This is a very, I know it sounds very science fiction, but it is the reality. Machine learning enables computers to think, to do a specific task based on their historical experiences without a human telling them exactly what needs to be done. They take a decision on their own. Now, what is a deep learning? This is the third part of it. Deep learning are specialized or advanced version of machine learning. By the way, when I talk about machine learning in a mathematical sense, these are complex mathematical equations. So machine learning, so deep learning is an advanced form of these machine learning equations or machine learning concepts, uh, which are becoming more common these days. But of course, with every advanced technology, you need more advanced hardware, you need much more advanced uh, humans to build those those technologies. But it's taking the intelligence of computers to the next level. Okay, I will now with that, I think this should help you now to really understand whenever you read a blog or come across someone. I've seen people mixing all of these three terminologies together. In a way, they all are part of the same group, but there are slight differences. Now, you may think, what is data science and where does it fit in? Data science would comprise of around 95% of machine learning, because machine learning is all about identifying historical patterns using complex mathematical equations to improve the performance in future. That is what around 95% of data science is all about. But there is a 5% which is slightly more. So if you combine that as well, which is around visualization of data, telling a story out of that data to people who can understand it. If you combine that, then that universe or that whole package together is what we consider as a data science in today's world. So to understand data science, one needs to understand what machine learning is all about. So I'll quickly go through the breakdown of the course. Then I will take a pause and we will open the forum for questions. So the course is for 8 weekends, Saturday, Sunday, 2 hours each weekend. Uh, the first 4 weekends are going to be around building the foundations and fundamentals. So the first one is the first section will be your nuts and bolts of going through, understanding what is GitHub and Kaggle. I'll talk more about both of these websites slightly later. So introduction to machine learning concepts, basic machine learning concepts, then understanding basic mathematics behind machine learning. Of course, the mathematics behind machine learning is vast. Uh, But good thing is it's everything that we have learned till 12th. And the bad thing is I will not be surprised if most of you have forgotten everything that we have learned till 12th in mathematics. So the base of machine learning is linear algebra and to large extent your differential calculus as well. Of course, I will not be covering differential calculus or linear algebra in these sessions because then we will need 8 weekends only to go through those topics. But I'm just giving you maybe I'll be just touching base on some of those topics so that you are not completely blank when we actually move into those machine learning algorithms. Then a problem solving approach, because end of the day, data science is all about solving a problem pertaining to uh, pertaining to data. Problem solving approach, there isn't as such a standard problem solving approach within data science, but there is something I have been following as my own practice for years. So I do talk about it for an hour so that if it helps you guys, it helps you. Then we move into the more core technical components. Introduction to Python programming language. Again, this is not a Python course, so I will not be teaching you or I will not be facilitating you to how to build websites using Python. That's not the whole purpose of this course. But enough Python that is required for you to build machine learning algorithms and to build any visualizations that you may want and conduct the data analysis using Python. Then we move into the machine learning algorithms. I cover the regression family of algorithms. When I say algorithms, these are nothing but mathematical equations. Algorithms are a set of activities or steps taken to solve a problem. That's like a fancier word coming from computer science. So then we move into tree-based algorithms, recommendation engines, like the kind of recommendations we get to see within YouTube, Netflix. So we will learn some of the most commonly used uh, techniques within creating recommendations for a user. Then a topic around clustering of data. This is a concept which is used for profiling of customers, identifying customer groups within a large amount of data. How this can be done through data intensive techniques such as clusterings. Then I move into portfolio management. Lot of focus during this course will be on building your portfolio because there are two ways you can learn or get into data science. One is the academic route, and the other one is more practical route, which is required from organization's point of view. So I've tried both. I have, during my professional career, there was a time wherein when I was I really wanted to learn more about this field. I took a sabbatical, I took a year break, I went back, I did my master's in this field. I'm still connected to certain professors. So I have an academic background as well into this, but then I know the difference of going through academic background and going through the corporate background. So if you want to go into the academic background, then you need to understand the all the differential calculus that happens behind every algorithm. But if you want to go through the corporate, I think most of you are here for that purpose to get a job. You won't be required to know the differential calculus working of an algorithm, but you should be able to understand which machine learning algorithm to use where and how to improve it to get the best performance possible. That's what's more required from the business point of view. So the focus of this course will be on building your portfolio. How do we build this portfolio? Again, it comes back to GitHub and Kaggle websites. I'll talk about it after the next slide. So that will give you a better understanding about portfolio management. And then the next 3 weekends, I will be covering, I give specific treatment to text-based data because today more than 60% of our data is text-based. So I will be covering basic concepts of how do we convert text data such as it's a feedbacks, comments, then your articles into a numerical form which your computer can understand and can be analyzed. Then there are specific algorithms which tend to work better to analyze the text related data, to find sentiments from the data, to find certain key patterns from the data. So we will be learning those algorithms as well. And then some advanced text processing concepts which are more common to deep learning. Now there is still 1 weekend left. So 4 plus 3 is 7. But I initially told you I take the course is for 8 weekends. The final weekend I will be investing, I'll be covering an optional topic. That optional topic I will be sharing with the teams. So this is what I generally do. I've like so far I've covered almost 10 batches over the last 2 years, 2.5 years. So after 3 4 weeks down the line, I will request the participants to pick one optional topic, and based on that topic, so topics are introduction to deep learning. I do not cover details of deep learning in this because deep learning will need at least 10 to 12. So I have a separate session that I'm planning for deep learning, but for that I want people who are already into machine learning field. That's the prerequisite for it. So, but giving you an introduction to deep learning, that can be 1 weekend or 1 weekend around data visualization, which I mentioned, which is a 5% part of the data science. Some of the best practices, do's and don'ts within the field of data visualization as well. So both of these are like open as an optional, and whatever the majority goes with, I go with that. So far, I've seen out of 10 batches, 8 batches I've always opted for deep learning. So that's 1 weekend which is optional. Uh, Generally, I've seen these sessions of mine go on for 10 weekends because generally I do not wish to rush. Sometimes I feel that maybe I need to go slow, or maybe sometimes I feel that I need to cover certain topics additionally, or maybe I need to recap certain topics, or even at times I may feel that uh, there is something new that I have come across. I wish to tell you more about it. So generally, I would say that you can add 2 weekends into buffer. So typically, it's like a 10 weekends course that I do on weekends. Now, finally, the most important, which helps you to get a, which will help you to prepare for a job, is your portfolio management. There are 3 ways you can do that. The first two are the bare minimum: having a profile on Kaggle website and having a profile on GitHub. I'm sure many of you would be having a profile on Instagram or on Facebook. What is a profile? Profile helps for others to see what you are up to or what are you doing. Facebook helps to see people what are you into in your personal life. What are you doing right now? Similarly, Kaggle profiles help recruiters to understand the kind of work that you are doing within the world of data science. So we'll quickly take a look at what Kaggle is all about. So this is my Kaggle page. This is my homepage. This one link on your resume is much powerful than showcasing any professional resume if you're looking for a data science jobs. Why? Because this is a platform wherein the world's finest companies, world's most well-known academics, they upload real-world data and let people participate in different competitions or let people provide their solutions based on data analysis through these data sets. And if I just go through the competition data sets, you would see that there are, even dollar prizes. Well, it's not that important that to get a job you need to be winning these competitions, but this helps in two ways. First, and this is how it has helped me over the last 7 years. I think a member of Kaggle for last how many years now? Almost 9 years now, and I'm very much active on Kaggle. Whenever I get time, I do something on Kaggle. So this portfolio helps people to see the amount of work that you have done, if you have participated in any competitions. So there are two things that you get out of it. One, you get to see the coding for a given data set. So let's say if I open one, get any, mm, let's say physical exercise recognition data set. Someone would have uploaded this. You will even have codes. So if you work on this data set, you are expected to submit your solution on this, wherein other users can actually see the outcome of your solution. So this helps you to even improve your own coding. It helps you to come across new solutions. It also helps you to understand what's new that's happening. So you learn. Seeing others, you learn a lot. So that's your first goal. Second, it helps the recruiters to see your efforts in this field. So it's like you are marketing your skills. You are learning from others and you are marketing your skills. This is the most. So when I go for it, when I ask for interviews, I opt for looking for resumes for interviews. I always ask to shortlist those candidates for a round with me, those who have Kaggle profiles. Doesn't matter if someone writes, I have 6 years of experience. I don't care. I have not been into your company. I haven't seen your work. I want to see how much active you are on Kaggle, what different variety of problems you have solved on Kaggle. And only on that basis, I call people for candidates. Just to give you an example, couple of years back, I was interviewing just prior to the lockdowns. So that's like 2019. I was interviewing candidates from IIT Chennai and for MTech candidates finally for a role within my team. So there were like four resumes that my colleague was shortlisting, soft copy of resumes, and all out of that one he looked at and said, yeah, I mean, people need to understand if they're going for a good job coming out of IIT, they should at least put something on their resume. I was like, show me. I was curious to see like who wouldn't put anything on your resume apart from like you have done your MTech. So there was this lady. I saw that there were two links. One was out of Kaggle, the other one was that of her personal website. I opened that link to her Kaggle, and the amount and the kind of project she did as over the last 2 years as her to improve her skills. Honestly, those kind of projects even we were not doing in our organization. I spoke to her, and we offered her the job. But unfortunately, for us, she was already she got shortlisted by another slightly larger bank. So doesn't matter what work you have done, but if you have a strong Kaggle profile, it adds tremendous weightage to your um, profile. So it's like a marketing skill. Second is a place called as GitHub. So GitHub is a place where we post our codes, our projects. So consider this like your cloud environment for your code. So like you have Google Photos where you upload your photos. Similarly, we have GitHub. Now the good thing about GitHub is if something happens to your laptop, and you can always have a backup copy on GitHub. So GitHub is also used to track the uh, usage of a person of that GitHub. So how active a person is on GitHub, that helps to track the amount of work the person has done in a particular field. So that's another place. So even this link and Kaggle link are the two most important links on your profiles. So now let me come to the final piece, and then we will open the forum for discussion. All right, the learning methodology. What sort of learning methodology I follow? Uh, so I've broken down the overall learning into, again, this is coming more from my own experience, how well you learn a complex topic. So you have 30% of your knowledge you will gain when you attend these sessions. I call this as supported learning. If you attend only my sessions, you will get 30% of knowledge. 30% comes from self-learning. At the end of every weekend, I will be giving a good amount of assignments. All of those assignments will be data sets on Kaggle, wherein I would be asking you to solve it on Kaggle itself, so that it you are solving your assignments, improving your skill, as well as doing projects on Kaggle itself. That increases the number of project count in your profile. That will give you 30%. So 30, 60%. The remaining 40% comes from social learning. So what is social learning? Social learning today, we have access to social media. Like we have access to Kaggle, checking out how others have solved it for the same data set, taking learning something out of their code. Maybe from their code you may come across a new algorithm that they might have used which you have not heard of. You would end up going and exploring. It's a natural phase. You end up exploring it. You learn more by doing that. At the end of each session, I will be giving you, apart from assignments, I will also give you certain blogs to read. These would be like 8 minutes blog, 10 minutes blog. So a 10-minute blog, I think you should be able to find time in your 5 days or 6 days till we meet again for the next weekend. And I generally start my next session. So if like today, the Sunday, the weekends got over, next Saturday I spend 20 minutes asking questions around the article that I've asked users to go through. That way, if you have any doubts, you bring it up. We have more like an open forum conversation, and we move ahead. What I don't do, and this is like my own my expectations from you. If you are expecting that I will be teaching you spoon feeding you concepts, you are wasting your time. That's not what I do. None of us are in the age of teaching. I cannot teach you. All of you are well above that particular threshold of age where a person needs to be taught. I will be facilitating your learning. I'll just show you something very interesting. Just some time back, yeah, I'm not sure if you're able to see this. I just received this book today morning from Amazon. Um, Something I need to read over the next 1 month. Of course, I may not be able to read the entire thing, but certain chapters I want to read. So even after 10 years, I need to read, I need to learn, I need to study. I spend a lot of a good data science professional spends a lot of time reading, studying, understanding what's happening in the world, and trying to try out in his own work. So study is part of our role. If you are someone who does not like to study, please figure out some other role. This is not the field for you. If you feel that you are happy in a stable life, this field is not meant for you. At every given moment, you need to study. You need to implement something. You need to unlearn what you have learned. All right. So now coming to expectations, if you are a fresher, how much efforts should you invest? If you really want to be ready for any kind of interviews, you should be spending at least 18 hours a week studying, because my expectations from freshers will be much higher. You should be figuring out and spending 18 hours per week going through the assignments, going through the blogs, and should be focusing more on your studies per week learning data science. Those who are working professionals, I would expect at least minimum 8 hours over and beyond your 2 hours of sessions. If you're able to invest this much over the next, not 2 weekends, but at least 4 to 5 months, not 2 months, but 4 to 5 months, because post 2 months, there is a roadmap that I generally share with all my batches. You will have to, whatever you have learned, you will have to fine tune it. There may be additional algorithms which I wouldn't have taught. Like even in the course, there are instances wherein after completing regression family, there could be couple of subsets of regression that I will not cover. Rather, I will give you links to their academic papers, and I will ask you to read and implement them on data set. You will have to learn on your own some of the algorithms. That's how you are then automatically getting into the actual work profile of a data science. So if you think you can invest so much amount of efforts, then this is a fantastic field to be in. If not, then maybe there are other things that you can try out. So this is one thing I definitely let everyone know, that if you guys feel that okay, doing weekends you will be ready for interviews and all. Sorry, boss, it doesn't work like that. I interview at least 20 to 25 candidates almost per month, wherein 95% of them are completely useless. Why? Because they are not investing time in studying, they are not investing time in understanding more about the concepts. Writing a piece of code is no brainer. There are a complex algorithm that does face detection is can be implemented using 3 or 4 lines. That's it, done within the Python. But that can be done by anyone. Why would someone pay you more than a regular software developer? That additional niche that you command will come from your understanding of how that algorithm that identifies the face work. If you want to improve it, what are different parameters of that equation you need to improve? So it's a very studious role. Um, Anyway, so with that, I hope the session helped you to understand the basics of what data science is all about, how my learning or how my facilitation techniques are going to be, what the course is all about, and I will open the forum now. So please feel free to ask questions. Do not hesitate, and I'll be more than happy to try and resolve any doubts that you may have. So the forum is open, guys. Please utilize it. We have 10 minutes, so please feel free. Yes, yes, Bidev. Bidev, I saw you raising a hand. So if in case you have a question, please. Yeah, yeah. So please unmute yourself and ask the question.
Yeah, I'm sorry. Yeah, hi everyone.
Yeah.
Hello, sir. Now, I'm from a purely non-technical background, a non-engineering background. I work for a BPO, and I'm planning to move to IT. My concern is mathematics. Now,
Hmm.
what level of understanding of mathematics do I need? Is it a very advanced level, or intermediate, or just a beginner's level, so that I can prepare myself for that?
Hmm. Good question. So before I answer, let me give you my own background. I am an engineer. I am a mechanical engineer, but uh, I started coding only 10 years back when I wanted to get into this field. So the first 7 years of my career, I was into a completely non-programming field. I didn't do a
Mm-hmm.
single line of code. So I think if
Mm-hmm.
I can do programming today, I can relatively comfortably do programming in 7 different languages. So if I
Mm-hmm.
can do programming, I think a lot of people can do programming. It's not a rocket science altogether. Now
Mm-hmm.
coming back to a question of maths,
Mm-hmm.
intermediary understanding of maths is helpful. Does it mean that you need to understand differential calculus? Uh, well, the answer is yes and no. Yes, in a way, is if you really want to be if you really want to stand out of 10 good, I'm using the word good with underline, 10
Mm-hmm.
good data science engineers or professionals, then you
Mm-hmm.
also, to demonstrate how you are different than others, you need to understand the back end working of those mathematical equations, how those equations are working, what are the things which are going as part of the components of that.
Mm-hmm.
But that does not mean not knowing it will not deter you from being a good data science professional. I have seen people, like even in my own master's batch, we had one candidate who was from arts, and they always give this example. And uh, she had maths plus arts background, but her maths she left after first year. Then she moved into arts, and that was the story with her.
Mm-hmm.
She was working with Times Now back then, and coincidentally, her boss was Arnab. And
Mm-hmm.
Arnab had pushed her back in 2014 to get into this field. Uh,
Mm-hmm.
Ar- so Arnab, as in Arnab Goswami. So she, even she got shortlisted to masters along with us, and she initially struggled. At the end of the course, she was the second, as per the rank out of 50 professionals who were part of that course of elite university. So I
Mm-hmm.
did this course from SPJ in Mumbai, and
Mm-hmm.
so she was second in a group of people who had background in working in likes of Amazon, Google, or from investment banks.
Mm-hmm.
So an intermediate understanding will be helpful. You need not know advanced because you do not wish to. I mean, expectation is not for you to get into the academic side of data science. Then you don't need that. And as far as implementation of data science is concerned, you would need a basic understanding of, or an intermediate understanding of how that algorithm is working. That's more than enough. So a lot of maths will not be required. At least for
Mm-hmm.
implementing a data science solution, you need, I think, 20% or 30% understanding of how that algorithm, how that machine learning brain is actually working. And you can invest, I think, few hours going through it, and that should be good enough. But then, of course, if you really want to stand out among a group of good, again, many a times even being good is more than great. But if you want to be different than people who are good, then I think it
Mm-hmm.
makes more sense for you to really upskill yourself on more advanced mathematical concepts which are being used in machine learning. Hi, hi. So as far as the jobs are concerned, either startups can be one place initially.
Mm-hmm.
So a lot of startups, I think almost more than 95% of startups are looking for people who can dabble into data science. Um, a, a year with, again, this is my perspective, but you can, always have. So I'll give you both the perspectives. First is
Mm-hmm.
opt for startups. Be ready to invest 10 to 14 hours per week per day to work and gain the exposure and experience.
Mm-hmm.
The experience of working with a startup for a year in this field is at least 5 years that of a company, like a stable company like Infosys or TCS. Yeah, well, the first year your packages will not be as high as what you would get elsewhere, but that
Mm-hmm.
experience will help you to propel your career. And after, let's say, even 14 months, 18 months, that experience, then you can move into more established large organizations, either into e-commerce or into financial institutions and services.
Mhm.
Even you can try and go back to the BPO sector, IT sector. A lot of these companies such as EXLs, WNS, they are getting into uh, data science nowadays. So they have
Mhm.
it within their teams on data science, wherein they analyze a lot of the data that they have and try and add more value to the clients as well. So that's one. Or second, you can always try out directly. Even either you can go back to the sector from where you are in. So
Mhm.
you can try out organizations which are already the the ITS organizations, like the example that I gave you of WNS, EXLs. They have a large requirement, or HCL, they have a large requirement for freshers with data science background or exposure. And since you already have that background, that will be an additional help. So
Mhm.
that can be an avenue to try out as well. Yes. Any other questions, guys?
Yeah, hi, this
Now,
is Bharti.
Hi, Bharti.
So I'm also from the non-technical background and I'm working with TCS as a lead.
Mm-hmm.
So my question is like, should we go first for the data analytics and then the data science? And what is the difference between this? Because I heard that those people who are non-technical from the non-technical background,
Honestly,
they
I do
should
not know what
only.
is the difference. I do not know who has come up with this jargon of data analytics. I hear this a lot. It's a nonsense
Mhm.
jargon. Um,
Okay.
End of the day, it's all about analyzing data. See, data science, data analytics, data analysis, data mining, all of these are variations of the same concept, which is analyzing a given data set, bringing out patterns from this data. Now, to bring out these patterns, since the
Mm-hmm.
amount of data is so large, we can't just use Excel. Excel will crash.
Right.
That's where having an
Right.
understanding of Python or some programming language is important. That's where this flavor of computer science also comes into this field. And since you're analyzing data, which means you're basically maths, you're analyzing numbers. Hence, maths is also required. So I think
Okay.
it's same. People have just created weird. I honestly I do not know, ma'am. Like what data analytics. I'm still trying to figure out what does it mean by data analytics. I've asked people.
Mm-hmm.
I've spoken to people who are in the role of data analytics, and I've been asking them, what is that? What you are doing, which is out of the world. I've never heard of it.
Okay. So
So
it's the conclusion is nothing data science
what
and
is that you have heard about data analytics? Let me try and maybe it will help
no,
me
I
to
just
answer.
heard, I mean, like, as I'm from the non-technical background, so
Mhm.
there's some experience required of coding and something like that to become a data
Coding,
scientist.
yes, is helpful because you would be using Python predominantly for analyzing this data. So you will be requiring to do coding. See, this role will include 100% coding. The
Okay.
data that all the analysis that we do, we use only programming language to analyze. We can't, because the amount of data, not only the amount. Like for example, if you're analyzing a video, how will you use Excel sheet to analyze the video? That's where you need a programming language.
Okay. Got it. And one last question I have, like, in terms of the placement services, like I do have experience, but that is not in data science. So how it would work? Will my
See,
experience
I
be
think you should
considered
utilize your experience. This is what I tell every experienced candidate. You don't
like? Hmm.
consider your experience as not of use. Your domain experience, your course experience will be helpful. You have to
Hmm.
channelize it accordingly. And that's what I even help candidates in the interview preparation that I do. Now, again, interview preparation I do only for those candidates who complete, sorry, who complete the entire roadmap that I give after the 2 months. So during
Okay.
that, I do recommend that if you're coming from a specific domain,
Hmm.
and if you have several years of experience, do not completely go away from it. So for example, so may I know what, if you can give me a bit of an idea about your profile?
Yeah.
So, yeah.
So I am working for an insurance domain for property and casualty. So I do have around 8 years of experience. I work with Cognizant, EXL, and now I'm working with TCS. So it's all about the insurance domain.
Good. I
So
mean,
work for the US clients.
coincidentally, I started my career in insurance domain in 2006 after completing my engineering. I mean, of course, from engineering, how what I was doing in insurance domain, it's still a mystery to me. But I was working for an American insurance firm into the project management side of the
Mm-hmm.
organization. So, insurance data science has tremendous um, scope within insurance. A lot of the examples that we may be seeing even in the course, we'll have some
Mm-hmm.
examples coming from data from insurance. A lot of this claims processing that happens, your claims
Right.
adjustment, claims processing, it does
Right.
involve data science today. A lot of machine learning algorithms are doing the initial screening to identify
Mm-hmm.
fraudulent and genuine claims, even
Right.
to uh, uh, approve the applicant's application for any new issuances. There is
Mm-hmm.
a good amount of machine learning algorithms are utilized.
Yeah.
Uh,
Right.
so, like for example, if so, you are right now a lead in a team.
Yeah. I'm handling a team of 10 people.
Great. So now I'm sure you must be also working on some sort of, you would be having additional requirement for making improvements, process improvements in the team,
Right.
in your process,
Right. Right.
right?
Yeah. Right.
You can
Yeah.
use data science to do that. You
Okay.
can use the
Cool.
tools within the data
Mhm.
science to do that. Now imagine this, how many leads would have this niche skill set as compared to what you have? What you would be doing, 90% of the other leads across the industry are also doing the same. So how are you different?
Right.
This is where you
That's
can
why.
add this additional niche that you can bring to the table. And even within your organization, or maybe you can showcase this to make that point. So I think you have a tremendous exposure. Completely giving it up and moving into a out and out data science. Rather than that, I would recommend you use data science, pick up tool. For example, clustering methods in machine learning is commonly
Mhm.
used for a lot of analysis that you can do. Maybe you can start showcasing small things like these to get the value out of the process. Try to bring that change, and I'm sure, I mean, TCS has got a lot of data science opportunities within the team. So even through in fact, I know one of my candidates, past candidate, moved
Mhm.
from the business. I forgot in which domain she was in TCS, but she took an
Mhm.
IGP and moved into data science team. And one of the reasons she was picked up because of her vast experience in that domain. So many of the data science engineers may not have, in fact most of them don't have the understanding of the domain. That's, some of them may be excellent in coding, excellent in math, but they may lack the domain. uh,
Right. Understood. Thank you.
so you can utilize that even within your domain. You did not have to completely get, get rid of your past experience.
Yeah. Yeah.
Yeah,
Agreed. Thank you.
you're welcome. Yes, Bidev.
Okay. Now, what about our doubt clearing sessions, or how it's going to
See,
work?
generally, you can reach out to me on my WhatsApp. You will have a common
Uh-huh.
WhatsApp. You can either,
Uh-huh.
if you have, I would always recommend to create, rather than asking me one question at a time, try and
Mm-hmm.
create a list of queries. Drop me an
Mm-hmm.
email, and maybe over
Mm-hmm.
one of the days on weekdays, preferably at night. So I wrap up my work by 9:30. So maybe
Mm-hmm.
in the late evening I can catch up, or maybe on one of the weekends after the session we can
Mm-hmm.
extend the session, and
Mm-hmm.
we can go through your overall doubts. And if the doubts are quite common, I may even cover them in the first 20 minutes of the session as well, so that others are also aware of it.
Mm-hmm. Absolutely.
Okay, one last question if anyone has. Cool, then. I think we are all good. Thanks a lot. Thanks for being patient. I hope you take an informed decision. I would recommend do a little bit more research before you decide if this is the
Mhm.
right field for you. And if it is, then be prepared to really invest good amount of hours, be prepared to burn the midnight oil. But as far as the field is concerned, trust me, after 10 years I am still exploring something new in this field. It's a fabulous field to be in. You never get bored because there is so much to learn and so much new that comes out every day, that as long as you are in this field, you will continue to learn. And I think as much as I've, the point at which I am, that even if at some point I'm done with my corporate life, I would still be associated with this field because it's such an exciting field. But then yes, it's all about you also dedicating that efforts, spending time. And on that note, I wish you all the very luck. I hope whatever decisions you take in your life, it fulfills all your dreams and your wishes. And in case you wish to join the sessions, I'd be more than happy to have you as part of the journey. So thanks a lot, guys. Have a great day ahead. Bye.
Thank you.
Sure.
Thank you,
Bye.
Parag. Bye.